The last couple of examples in 1-6 are going to deal with other type of equations, but we're going to use factoring to solve them, okay? And I'm going to let you know that they look different, okay? That's why they don't have a true name, so to speak, okay? So this is still in 1-6, and like I said, I just grouped these into the whole others category. First, let's look at a fourth degree. X to the fourth plus 2x squared minus 15 equals 0. Now, I did mention that even in this other section, I'm going to factor. And there are two main reasons why I say I'm going to factor. One, it's a trinomial, okay? And normally, you can factor trinomials if this one situation occurs, meaning my exponents. If your middle exponent, the middle term, if his exponent is half of the first one, then you can set it up in factor form, all right? Remember, you might not, don't write this, this has nothing to do with the problem, but when we factor, and I'm just going to take it down to second degree, normal factoring, when I give you a trinomial, you got x squared and then you got an x term. You follow where I'm going with this? And so when you do your two parentheses, you put x at the front because 1 and 1 make 2. Does that make sense? So when I take it from second degree to a fourth degree, it's 2 half of 4. Yes. So I still can do my two parentheses. This time, instead of me putting just x at the front, I got to put x what? Squared. Good. So I need that thought process is going to be in play for the next couple of examples, no matter how they look. Because as long as that middle term, that exponent, if it's half of that first one, we're going to set it up as a factor problem. Okay? So I'm going to do my two parentheses. And we said we're going to put x squares at the front. Now, our rules for factoring are the same. We're going to look at that back sign. It's a negative, which means we're subtracting to get 2. So we only have really one set of numbers that's in the back that we're looking at with 15. So what factor pair of 15 are going to subtract and give you a 2? 5 and 3. So we're going to stick that in the back. 5 and 3. Does everyone see what we're doing? Same factoring. And if you need to go over to the side and do outside, inside, that gives me the 3x squared, 5x squared. That'll make a 2, but make sure your signs are right. 2 is positive, so who has to be positive? My 5. My 3 is negative. So the factoring part we should know. Okay, that's not a new concept. What the concept I'm showing is making sure you understand how I factored it from fourth degree to split it to 2, x squared, x squared, okay? Now, if I'm got it set equal to 0, I want you to tell me what is x, all right? Just like we've been doing. You set each parenthesis to 0 and solve, okay? That's zero factor property. You're going to take each parenthesis and set it to 0 to solve. Now, this incorporates what we have already talked about. That's why it's so crucial for you to really understand math when you go over something, because it builds. You got 2 terms. X squared plus 5 equals 0. That's 2 terms. What method are we going to use to solve for x when you got 2 terms and one of them is squared? Square root. Very good. Quadratic form, I got to have 3. Square root, that's what we did on the last test, on 1-4. When you got 2 terms, you do the square root method. So that means you get x by itself by subtracting 5, move 5 over, and it becomes a negative 5. And then to get rid of that little 2, we take the square root, and you do both sides. And so x equals Plus or minus, good. You cannot forget that when you do square root method. That's part of it, good. And how we break down the square root of -5? I square root of 5. Good. That's 2 answers. Okay? This problem has 4 total answers. It's a 4th degree. Okay? So you got positive I square root of 5 and you got negative I square root of 5. Now go over to the second parenthesis and do the same thing. X squared minus 3 equals 0. So we're going to get x squared by itself by adding 3. And then we take the square root. Good. So x equals plus or minus. Do I need I? Because it's not negative. We just bring down square root of what? 3. Very good. Do y'all see that? Those are your 4 answers. And like I said, it looks different, but we're doing the same stuff, though. It's just in a different way. I'm still factoring, and then I'm doing square root property. Does everybody see that? Because it's squared. Now, I will throw out this disclaimer, because I do know some of you, students, it's just a habit. They love when they get on my labs, clicking on that help me solve. Help me solve is going to show this using substitution, and I don't teach substitution. Substitution is where you put in another variable for what you're looking for. Now, I just don't like adding more mess to what I already have because you still got to come back and plug in x squared. It ain't going to go away. So I just want to throw that out there. If you're going to rely out, that's why I take notes. That's the reason why I go through problems. So let this be your guide when you're doing your homework. Because if you click on the help me solve, they're going to show you textbook method, which is going to be substitution, where they plug in U's or they plug in a P, and then you got to come back and plug it back in. It just makes your factoring look pretty. And I ain't caring about the factoring looking pretty, okay? Because I still got to deal with it. Does that make sense? Let's look at another. Y'all got any questions on this example? Number 2. 2x to the 4th minus 7x squared plus 5 equals 0. Okay? We're going to factor it. It's 3 terms. And I can set it up with x squares in the front. So I'm going to set my 2 parentheses. Just keep in mind this time your front has a 2. So you got to put that in front of one of them x squares, okay? So you got like a 2x squared and a 1x squared. Now, if we're adding to get 7, and we only have one option, because you got 2 and 1 in the front, and you got 5 and 1 in the back, and what's 5 plus 2? 7. You see what I'm saying? That's going to have to work. So I'm going to put the 5 with the 2, and put 1 back there with the x squared. And if you need to do your outside, inside to check that, that makes a 2x squared and a 5x squared. And if you add that up, that makes 7. Now 7 is negative, so what does that mean when we're adding? 5 and the 2 has to be negative. Everybody got to carry the same sign when you add. Okay, so that's the factoring part. Now we take both parentheses and set it to what? To 0. Okay. So here we go. On the first one, we're going to add 5 to the other side and then divide by 2. And you got x squared equals 5 over 2. So now I take the square root. Good. So that's going to give me x equals plus or minus Okay? Now, he said the square root of 5 over the square root of 2. Now, this is something that you might not know, okay? But when we went over radicals, I might have said it, I'm trying to remember, but radicals are not supposed to be on the bottom of a fraction, okay? That's kind of like an illegal write-up in algebra. So that square root of 2 going to have to change to a whole number. So in order for it to change to a whole number, we do something called rationalize. And in order to rationalize, that means I got to multiply it by something that's going to turn that to a whole number. So when I think about radicals, in other words, I got to make it perfect. Because that's the only way. Think about it. The only way a square root going to change to a whole number is if I take the square root of a perfect number. Does that make sense? So thinking about you got the square root of 2, what's the first, the closest perfect number I can make on the bottom? Give me the perfect number. If you need your chart, look at it. What's the first, when you got with 2 now, something 2 can go into, what's the first perfect number I can make? 4. Very good. I can make 4. Okay? So I need this to equal the square root of 4 on the bottom. Because isn't that 2? Ain't that a perfect number? No house? Because that's what I don't need a house. So what would I need to multiply by to get the square root of 4? Square root of 2. What you just did is called rationalizing. Now, because this got to be balanced, it's a fraction. You can't just do it to the bottom. You also have to do the same thing to the what? To the top, okay? And I'm going to write that word. This $10 word is called rationalize. That's what you're doing. So whatever, and really you don't have to think about it too hard. If I would have had the square root of 3 on the bottom, you're going to multiply by the square root of 3. Because wouldn't that make 9? And ain't that just 3? So the neat thing with square roots is it's always you multiply by what it is. Because it's going to cancel itself out. Does that make sense? If you had the square root of 5, you multiply by the square root of 5, and that's going to make 25, which is what? 5. You follow where I'm going with this? So that's the key with rationalizing. You always multiply by whatever's on the bottom. Because it's going to cancel itself out to a whole number. Does that make sense? So with that being said, on top, that's going to make the square root of who? 10. So really our answer is plus or minus. Now we know we can't do nothing with the square root of 10. Right? Because there's no perfect number in it. So it stays in the house, but my bottom number changes to what? 2. Very good. Those are your first 2 answers. Plus or minus the square root of 10 over 2. Okay? Now, all seriousness, am I going to really give you one like this on my test that has the rationalizing? No. But I want to show it to you. Does that make sense what I'm saying? I'm going to give you a more like the first example, if I give you a 4th degree, where you just straight do square root property. But I do want it to present how, if you have a number on the front, like that 2 on that x to the 4, you're going to probably have to rationalize. Okay? Now, the other 2 answers, x squared minus 1 equals 0 from the second parenthesis. Now, you can do that 1 or 2 ways. Now, really, that's the difference of squares, if you want to factor it. Or we can do square root. Add 1, take the square root, and x is going to equal who? Plus or minus what? Which is what? 1. Just 1. Square root of 1 is just 1. Do y'all see that? Questions? No? Okay. Number 3. 7x to the negative second power minus 10x to the negative first minus 8 equals 0. Now this is the second type of others, which is negative exponents, okay? Now, I'm still going to factor because I have 3 terms. Do you agree? I got 3 terms. And when I look at that middle term, his exponent, isn't negative 1 half of negative 2? Yes. So I need y'all to see the dynamics. So when I do my 2 parentheses, like on the last one, I had 4, so I put 2 and 2 at the front on the x. Now that I have negative 2, my middle is negative 1, so what would go at the front? I'm talking about just x part. How would I split to do my 2 parentheses? X to the negative 1. Because in negative 1 plus negative 1, negative 2. So I'm going to put x to the negative first at the front. Do y'all understand that? Now, in the front, you also have a 7. Now, 7 doesn't have but one factor. So one of them got to have a what in front? A 7. Does everyone see? I'm regular factoring. It's just that my x looks different on all of these, and that's the key. But it's not anything hard. I just need y'all to see why I'm using x to the negative 1, because that's what I'm dealing with. And I got 2, so obviously half of 2 is 1. Does that make sense? Now, my factoring rules are the same. We are subtracting to get that negative 10. So with 8, you got 1 and 8 and 2 and 4. Keep in mind there's a 7 already up there. So who do you want to use? 2 and the 4. And we're going to put the 2 across from 7, because that makes 14. Does that make sense? And then 4 is inside. And if you subtract them 2, does that make 10? Mm-hmm. Now 10 is negative, and I'm subtracting. So who has to carry the negative? Now when you subtract, who? The 14, so that's going to be what, the 2? And the 4 is going to be positive. Does everyone see that? Now this thing is equal to 0. So still, I'm trying to find what x is. So what do? Set each parenthesis to what? To 0. Okay? So even if you don't know what this negative exponent means, you got to get it by itself. Okay? I need to get all the numbers away from it so we know that process. Solve it like an equation. We're going to subtract, what, 4? And then divide by who? 7. Now, this is what this negative exponent means. And I could have said it at the beginning. But all negative exponents, if you remember your exponent rules, when we just went over them, when you got a negative exponent, we're supposed to do what with it? Flip or move, right? In this case, you're going to flip because it's on x, okay? I'm telling you, this negative exponent means to flip your answer. Flip what you just solved. Don't change the sign. Just flip it, okay? So your answer is technically negative who? 7/4. You factored it just the same. You just got to remember, I got to flip my answer, okay? Just flip it. On the second one, what you going to add 2 to the other side? Right? And so that's technically 2 over 1. So if you flip it, because that's what that negative 1 means, x is really what? 1/2. Good. No changing signs. It just means flip. Does that make sense? And honestly, I have factored this without using x negative 1. I just regular factor it. And then in my mind, I know I got to do what with that answer? Flip it. Is really what that means. So if you wanted to factor real cute, just factor like you normally would. 7x in the front, x in the front, put your 4 and 2 back there, make it work with your signs. But when you pull out that number, you got to remember to do what with it? Flip it. Because the exponent is really negative. Does that make sense what I'm saying? Questions? No? Okay. Let's do example 4. All right, here we go. Parenthesis x minus 1. Raise it to the 2/3 power. Plus parenthesis x minus 1. Raise it to the 1/3 power. Minus 12 equals 0. I say the best other for last. Now, do not focus on how bad this looks, because it looks bad, okay? But it's really a shorthand for something we just went over, and it's not that bad, okay? When I say shorthand, it's kind of like, like a short way of writing it, okay? Now, I need you, and I'm telling you, my lab's really going to use on this, but I need you to look at this. This is really 3 terms, okay? And as bad as it looks, my x is that parenthesis. Do you notice they got to match? The first and the second term, I couldn't make the parentheses be something different. You follow me? They got to be the same because I'm going to treat that like x, okay? Now, the whole fraction deal we've talked about, that's a rational exponent, okay? And we're going to deal with it once we get it factored. But I need you to set this up as a factor problem. When you look at, and I'm still doing this balance situation, where the middle term's exponent, if it's half of the first one, I can set it up as a factor. Even though that's a fraction, 1/3 plus 1/3 is what? 2/3. So it's half. Do you see? I'm still using half. Do y'all get where I'm going with this? So when I set this up, I'm going to put my ugly exponent is going to be 1/3 in front of both, because I need 1/3 and 1/3 to make that front one, which is 2/3. Does everybody understand that? So I'm going to do some big old parentheses. This thing, it's got them ugly X's that's in a parenthesis. Don't worry about that right now, okay? Your focus is, this is what you're looking at. I didn't give you nothing in front but a 1. Do y'all see this, okay? I didn't give you no coefficient number in front of it. It's just 1. So in front of both of my big old parentheses, I'm going to stick that so-called X to the 1/3. You follow me? Don't matter what's inside that parenthesis, that's your so-called X, okay? Stick it in the front, just like you would X. X minus 1 to the 1/3. X minus 1 to the 1/3. In my mind, that's X. Does everybody understand me? And 1/3 is my exponent. Now, I look at the back side. My factor rules are the same. It's negative, so that means I'm doing what? Subtracting. Now, what's the coefficient in front of my middle X? What's the coefficient? 1. Okay, I'm not making this hard. It's a 1. So if my back number is 12, what 2 numbers will make a 1 if I subtract? 4 and 3. So that goes in the back. You're going to stick 4 and 3 in your back. 4, 3. Does everyone see this? In my head, this is what I see. X and 4 in one parenthesis, X and 3 in the other. That's what I need you to see. Even though it looks real funky. Does that make sense? Now, the sign is a plus. So that means who? 3 or 4 going to carry the plus? My 4. 3 is going to be what? Negative. Does everyone see? Now that's I factored it. I factored it. Now, I need you to find X. Now this is where you would, if you substituted that parenthesis to the 1/3 as you would have to come back right here and plug it right back in. Because you got to use it. Okay? So we're going to set both big parentheses to 0. X minus 1 to the 1/3 plus 4 equals 0. X minus 1 to the 1/3 minus 3 equals 0. Now, go back to what we did in R7. This is coming out of our rational exponent section. 1/3. What does 1/3 mean if it's an exponent? We talked about this. When I give you a fraction as an exponent, 1/3 stands for something else. Cube root. There we go. This is nothing but shorthand for a radical. I really could rewrite it like this. The cube root of x minus 1 plus 4 equals 0. That's the exact same sentence. Do y'all see? I'm not changing. It looked different. So I need that to key in. When you see these fractions as an exponent, it needs to key in that, okay, this is really radicals. This is cube roots because the bottom is a cube of 3. Does that make sense? So we just went over radicals. I got to get rid of it, so I do what first? How do I set up solving for a radical? Get it by itself. Good. So I'm going to do what with 4? Subtract it. Awesome. Okay? Then what? Cube both sides. Very good. That's how you get rid of that house. That's my problem. I got to get rid of it. So you're going to cube both sides. That means raise it to the 3rd power. So you got x minus 1. That's what's left. The house cancels. Equals who? Which is negative 64. Last step to get x by itself. Basic equation. What you going to do? Add 1. So x equals negative 63. That's one answer. Do you see that?
So with these, what tells you how many answers you'll have?
Well, you're only going to have 2 answers. Okay, you're only going to have 2. They're fractions, but this one is not to a whole number. So it's going to be back like a regular quadratic. 2 answers. So go to the second one. We're going to do the same thing. If you want to write it as a root, that's fine. And we're going to do what with that negative 3? Add it. And then what we do? Cube both sides. Good. So we got x minus 1, bless you, equals 27. Last step. Add 1, so x equals 28. Those are your 2 answers. Yeah, I see that. And like I said, I know this looks real crazy, but I'm combining previous concepts in one problem. Does that make sense? I'm going to do one more of these to make sure you do have 2 good examples. X plus 1 to the 2/5 power minus 3 times x plus 1 to the 1/5 power plus 2 equals 0. Now, just right off the bat, what radical are we in? What root? Fifth root. Very good. It's fifth root. Does everybody understand? You got to remember what that exponent as a fraction means. The bottom number is your root. Okay? So we're going to set it up just like we did the last one. We're going to set it up as a factor. And again, I still didn't give you no number in the front. That's the key. I didn't give you nothing dead in the front of this thing. Okay? So what's going to go in the front of both parentheses? To the what? 1/5. Good. Because I need 1 and 1 to make 2. Does everybody see that? Now, our factoring is still simple. This time I'm adding, but I did give you a middle number. I didn't want to make it hard. I want you to give an example. Do y'all see that's a -3? So I'm adding to get -3. Does everybody see that? And you only have one option, because what's your back number? 2. So what's your option? 2 and 1. So you stick them in the back. Does that make sense? And if we adding, and that 3 is negative, that means they both got to be what? Negative. That's the rule. They both got to be negative. So that's the factoring. You've done it. Now we take each parenthesis and set it to what? To 0. And if you want to rewrite it, this would be the same as saying the 5th root of x plus 1 minus 2 equals 0. That's exactly what this means. So we're going to do what first? Get it by itself, add 2 to both sides, okay? Then what? Raise it to the 5th power. That's going to give us x plus 1 equals 32. Last step, do what to get x by itself? Subtract 1, so x is 31. Does that make sense? Okay. On the second one, you can write that as the 5th root of x plus 1 minus 1 equals 0. So how do we get that radical by itself? How? Yeah, how? Okay, move 1 over. Then we're going to take it to the 5th power. Good. And so that's going to give us x plus 1 equals just 1. Last step, subtract 1, so x is 2. 0. Now that doesn't mean like no solution or nothing. You can have 0 as an answer. So the answer is just 0. Do y'all see that? Now I didn't say this, I'm just getting to the answer. You throwing them 2 answers in my blank, x equals 31, x equals 0 is fine. But you do know my labs is probably going to do the set and I'll take the curly Q. So just want to make sure I do say that. Be a little proper with it. They probably going to put it in this notation form. But that's it. There's only 3 different types of other quadratic form equations. And so that was the 4th degree, the negative exponent, and then the rational. Okay, and all that means now, 4th degree means I split it into x squares, which means I got to do square root property. Then you have the negative exponent, which means, okay, factor it like normal, technically, and flip my answer. That's really what that means. And then your fraction, your rational exponent, just simply means I'm going to factor it, however, I'm taking the root. Meaning I got to raise it to that root, that power, to cancel out the radical, because there's nothing but radicals. Okay? questions on 1-6. This is the end of 1-6.